Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in the previous session, we have completed the image formation by spherical mirrors. Okay, this topic completed now, and after this, we have to discuss the mirror formula. Okay, mirror formula. Yes, mirror formula. It is very simple, guys. Mirror formula. If it is a mirror formula or lens formula, whatever it may be, I want to give three important points. The first point, here all the objects are in reciprocals. Okay. 1 by V, 1 by U, 1 by F. Okay. So that means here V, U and F are in the reciprocals. Must be in the reciprocals. Okay. So a small trick is nothing but lens less. Less means minus. Okay. So just remember this trick, lens less minus. So in the lens formula we have the minus. 1 by V minus 1 by U is equal to 1 by F. In the mirror formula, we have the plus. 1 by V plus 1 by U is equal to 1 by F. Okay. So it is a very simple formula. What is the first point I have given? All the three quantities V, U, F are the reciprocals. 1 by V, 1 by U, 1 by F. If it is a lens formula, lens less the minus 1 by V minus 1 by U is equal to 1 by F. Mirror formula 1 by V plus 1 by U is equal to 1 by F. Okay. So what is this V, U and F? You know very well F is the focal length. U is the object distance. U is object distance. Okay, object distance from its pole. Its pole. V is the image distance. Image distance from its pole. And focal length. F is the focal length. Focal length. Okay. F is the focal length. 1 by V plus 1 by U is equal to 1 by F. If it is a concave mirror, if it is a concave mirror, here it is the pole, it is the focus, it is the center of curvature. If you place object is here, object is here, from this place to this place is nothing but we can say U. Okay. So here it is the, if you can consider it is the origin, it is the positive x-axis, it is the negative x-axis. Okay. Generally you place the object is in the negative x-axis means for concave generally U is always negative. Okay. If the image formed, for example, if the image is formed here, okay, image is formed here. Here image is also formed in the negative x-axis means in that case V is negative. V is negative. If the image is formed here, if the image is formed here, that is positive x-axis, in this case V is considered as positive. All of you clear? If you place the object is in the x-axis, that is minus x-axis, that is real axis, okay, then U is negative. If the image is also formed same, so this is the V, image distance from its pole. It is also formed in the negative x-axis means it is also considered as negative. If it is in the virtual axis, okay, that is plus x-axis, then you can say V is the positive. V is the positive. Okay, so from this one we can understand V is negative means it is in the real axis. V is positive in the sense it is virtual axis. And I have given already in the previous, all real will be inverted, all virtual will be erect. Okay, if you can consider convex mirror, it is the convex, it is concave. You know very well. In the previous sessions I have given in detail. Okay, if you place your object is here, if you place your object is here for this concave mirror. Okay, if you can consider it is the horizon, it is the minus x-axis, it is the plus x-axis. Okay, so you have placed your object is in the negative x-axis means for this concave also always u is negative. Okay, and image formed may be always in the virtual axis now. Image formed always in the virtual axis. In the previous session I have given. So V is always positive. V is always positive. Okay, all of you clear? V is always positive. So you can note down for concave V is, let us take first of all U. Generally we may place negative x-axis, so it is always negative. V may be positive or negative. Okay, and in case of convex, what you got? U is always negative only. Why? Because you can always place in front. V always positive. Always positive. Okay, all of you clear? And I will give in detail about this in the MCQ session. Okay, in the MCQ session, I will solve some problems. From that, you can get a clear idea. Okay, you can get a clear idea. So don't forget to watch the MCQ sessions also. Okay. And coming to the next one, after this, we have to discuss the applications. Applications. I think I have already given the applications. Okay. Once again, I am giving concave mirror. Wherever we require magnification, wherever we require magnification, that is larger images, powerful beam, in those cases we go with the concave type. Examples, okay, all the searchlights, very very important guys. Searchlights, that is torch lights, okay, shaving mirrors, mirrors used by dentist mirrors, magnification and focus. Okay, so in case of dentist mirror, so dentist has to focus on the particular teeth which is having problem. Okay, so whenever there is a focusing is required, then also we use the concave type of the mirror. Okay, and large concave mirrors are used in the solar furnaces. In that we require large amount of heat, large amount of beam. And front light, headlight of vehicles, in all those we use the concave type. Convex type, wherever we require only virtual images, virtual and correct images, and image size is less than object. Okay, this requirement is used in rear view of vehicles and security mirrors. In those cases, we go with the convex type of the mirrors. Okay, that is sharp security systems. Sharp security systems. Now after this, we have to discuss plane mirror. Plane mirror is pending now. We have not discussed the plane mirror, so we have to discuss the plane mirror. Actually, we need to discuss the plane mirror as the first, but to understand the terms, I have given spherical mirrors. Okay, concave and convex. Plane mirror is nothing but, if you take a plane mirror, if you take a glass, one side is polished. If you polish one side, then it will be act as the plane mirror. It will be act as the plane mirror. So note down, reflecting surface of the mirror is plane. This is the reflecting surface. Reflecting surface of a mirror is plane. Okay, and here if you place object at a distance of u, okay, if you place any object at a distance of u, then the image formed will be also same distance. That means v is equal to u in plane mirror. V is equal to u in plane mirror. Okay, so note down, if you place object at u distance before the mirror, if you place the object at u distance before the mirror, then image formed will be with the same distance, from mirror. Okay, so that means v is equal to u. V is equal to u, and size of image is equal to size of object. Okay, that means linear magnification m is equal to v by u. Both are same means linear magnification is equal to 1. So linear magnification m is equal to 1 for plane mirror. We know this value for concave. In case of concave, there is a possibilities of all. M is equal to 1, m is greater than 1, m is less than 1. In case of convex, only v less than u. V less than u means m is less than 1. M is less than 1 only possible. M is less than 1 only possible. Okay. So we know very well in the convex, we have discussed already of this. These points we have already discussed. Okay. So just I have given summary here. Okay. Linear magnification is 1. And focal length of plane mirror is considered as infinity. There is no radius of curvature here. So radius of curvature is generally infinite. So focal length, very important point. Focal length of plane mirror is infinity. And here, if it is your object, for example, it is a plane mirror. If you have placed your object like this, A, B, and you are getting the image is also same like AB, correct? So images formed by plane mirror are virtual, correct? If you place your object is in negative x-axis, it is formed in the positive x-axis. So virtual plane mirror are virtual. All virtual will be erect. All virtual will be erect. Okay, so that's why if we see our face in the plane mirrors, generally we will get same type of the image. Okay, so all the virtual will be virtual images, all the virtual will be erect. Okay, virtual will be erect. Okay, and one more important point in the plane mirrors. Whenever the two plane mirrors are facing each other at one particular angle, then the number of images formed. So those type of the questions we are getting in the examinations. So note down that point, important formula. When two plane mirrors are facing each other with an angle theta, and an object placed between them, then the number of images formed n is equal to 360 by theta if theta is odd. If theta is odd. In case, sorry, not theta. If 360 by theta is odd. 360 by theta value is odd. Okay. In case if 360 by theta is even, then number of images form 360 by theta minus 1. That means we need to subtract with the minus 1. Okay. So with examples you can get understand. If 360 by theta value is odd in the sense, for example, if you have 3, 5, 7, 9, then number of images formed also same, 3, 5, 7, 9, like that. If 360 by theta value is like a 2, 4, 6, 8 in this manner, then number of images found will be 360 by theta minus 1, that is 2 minus 1 is 1, 4 minus 1 3, 6 minus 1 5, 8 minus 1 7. So from this one what you can say, 3, 5, 7, 9, 1, 3, 5, 7 all are odd. So number of images formed always odd only. Always odd only. All of you getting my point? So try to remember this important trick. Number of images formed always odd only. If they have given options with even, so you can easily eliminate those. Okay, take one example. If theta is equal to, I am giving 90 degrees, then how many number of images formed? So first of all we have to find out 360 by theta, that is 360 by 90. So number of images that is 360 by theta value is 4, but number of images formed is 360 by theta value is the even. Even means n is equal to 360 by theta minus 1 na? So there is no possibility of even images, only odd images of possible. So 4 minus 1, that is equal to 3. 3 is the answer. Okay, if they have given theta is equal to 120 degrees, then calculate 360 by theta value. 360 by 120, that is number of, that is 3. 3 is the odd. If it is the odd, what is the number of images formed? 360 by theta only. So that is equal to 3. Okay, so in all those cases 3 is only the answer. Okay, if you get 360 by theta value is the even, just subtract with the -1. If 360 by theta value is the odd, no need to subtract, that is the answer only. That is the answer only. Okay, all of you clear? Okay, for example, if theta is equal to 60 degrees, then calculate the 360 by theta. 360 by 60. So 6 is the even. Even means number of images formed will be 360 by theta -1. So 6 minus 1, that is equal to 5. Okay, no possibilities of even images when the two mirrors are placing with an angle of theta. Okay, I think all of you clear. Okay, so this plane mirrors is generally used in as the looking glass. Looking mirrors generally we are using in a houses now. And in case of periscope, what is the periscope? Periscope is nothing but that is used in case of wartime, or if you want to see any object on the from the underground or from under the sea. Okay, here under the sea or underground, if you want to see anything, you need one plane mirror here and another plane mirror here. Okay, so if any of your enemy is coming near to you, okay, that reflection will be fall here, and that will be reflected to this place, and that will be you can see from the underground or from under the sea. Here, why we use the plane mirror? Here, if you want to get exact idea and exact distance and exact size, okay, you need plane mirrors only. From the plane mirrors only you can get virtual, erect and same size images. That is possible by this plane mirrors only. So that's why in periscopes you use the plane mirrors. That is a very important question in the examinations. Okay, after this we have to discuss this reflection concept is completed. Now we have discussed refraction concept. Refraction, very important concept. Refraction, in the refraction case we need to discuss the lenses. Lenses have refraction phenomena. Mirrors are reflection, lenses are refraction. Okay, so now I want to discuss about refraction. So what is meant by refraction of light? Okay, you know very well reflection. Okay, what is the reflection? Reflection in the sense, whenever you send some light ray, it will be reflected back. If it is reflected back, then you can say that is a reflection. Mirrors, in the mirrors we have reflection concept. In case of lenses, we are using the contact lenses now, we are using the spectacles. In that, light is going through. Okay, light is going through. Okay, so in case of pure glasses, we can look into that. Okay, so here in the refraction of light, there is one important principle is there, that is whenever the light is traveled from one medium to another medium, it will be refracted. Refracted means just it changes its direction. It changes its direction. Okay, for example, light is traveling from denser medium to rarer medium. or rarer medium to denser medium, it will be refracted. It changes its direction. It bends its direction. That phenomena is nothing but you can say refraction. Okay. So change in the direction of propagation of light when it traveled from one medium to another medium is nothing but you can say refraction. This is a natural phenomena, guys. For example, if you are moving in the vehicle, okay, if you want to change your direction, then what you will do? You will change. You will be slow down, and then you will be take the turn. Correct? You will be take the turn. Or if you are moving very faster and if you brake suddenly, then also your direction of vehicle will be changes. Correct? Okay, you are moving the bike with a very fast speed. Suddenly, if you put a brake, then a small change in the direction of your vehicle takes place. Correct? So here also, whenever there is a changes in the medium from one medium to another medium, then due to the refractive indexes, the speed of light will be changes. Then it will be changes direction. Okay, so note down the refraction of the light, then you will get understand. Okay, so change in the direction of propagation of light when it moves or when it travels or when it passes from one medium to another medium. You can divide the mediums into two types. Okay, one is a denser medium, one is a rarer medium. Okay, so what is this denser and rarer medium? Denser medium is nothing but the speed of light in which is less, that is slow. You can say slow. Okay, the rarer medium is nothing but the speed of light in which is more, that is fast. Okay, so those mediums are rarer mediums. For example, we know very well speed of light in any medium is equal to depends upon inversely proportional with the refractive index. Correct? If you can consider air, refractive index is 1. If you can consider water, refractive index is 1.33. If you can consider diamond, it is 2.41. If you can consider glass, it is 1.65. Okay. So if the refractive index is less, speed is more. So that means for air, refractive index is less. So speed of the light in case of air is more now. So here generally air is considered as rarer medium. Air is considered as rarer medium. Okay, compare with air. By comparing with air, water, glass are denser mediums. Okay, by comparing with the air. By comparing with the glass, water will be a rarer medium. Correct? Water will be a rarer medium by comparing with the glass. So here comparison is the important. Okay. Here, sir, we are very confusing with this, sir. Sir, we don't want all this concept. We require just a trick to remember. Okay, in that case, you can make a small trick to remember. You can make a small trick to remember, that is dense. Okay, so here one is more rare. So rare, R is the domination, rare for more, rare for more. Okay, and R for air, R for air. So you can remember simply like that. Air, R for more, R for rare. Okay, so it is a rarer. So air, R is the domination, R for it is a rarer. In which speed of light, R for more, speed of light is more. Light is more. Okay, dense, yes, S for less. Okay, less, S is the domination here. Okay, denser medium, less. Okay, so here in which the speed of light is less, that is especially you can say glass. Glass, in the glass the speed of light is somewhat of less, correct or not, by comparing with the air. Okay, so and also by comparing with water also somewhat of denser only. Okay, denser only. Why? Because of high refractive index. Okay, all of you getting my point? So now here we have the two important points in the refraction of light. If we have the two mediums, means if the light travel from denser medium to rarer medium, what will happen? Rarer medium to denser medium, what will happen? So let us take the 2 points. Okay, if the light travels from, if light travels from denser medium to let us take denser medium as water, to rarer medium, or you want water, or let us take glass, is your wish. Okay, denser to rarer medium, then denser medium to rarer medium, it bends away from the normal, away from the, very important point. Okay, very important point. So let us take the two mediums. So denser medium I am taking here. Let us take a glass. Here I am taking rarer medium. Speed of light is more. Let us take air. Okay, let us take air. So if it is the incident ray, that is light is falling like this, and that line perpendicular is nothing but you can say generally normal. Okay, so I am extending the normal in the below axis also. Okay, so generally this is the actual way of the light. But what is happening, whenever there is a denser medium speed of light is less. Speed is less. Here speed is more. So if it has to increase the speed from less to high, okay, low to high, it will be bends in the horizontal manner. It will be bends like this. Okay, this is the normal, means how it is bending away from the normal. So away from the normal. So to gain high speed, so low to high, it is trying to move in the horizontal manner. Okay, so that means it will be moves away from the normal. In the same way, reverse. If light travels from, just should try to listen, guys. After that, I will give the trick. No need of worry. If light travels from rarer medium to denser medium, it bends towards to the normal. Towards to the normal. Okay. So if you can consider rarer medium. Rarer means more. More means air. Okay. So speed of light is more. So this is generally actual path. If there is no refraction, it is no bending, it is the actual path. If the mediums are same, the light will be travels like this. Incident. Okay. But here what is happening? It is moving from rarer to denser medium. Denser means speed of light is less. Okay. Speed of light is less. Let us take it is a glass. Okay. So speed from higher to lower. Speed high to low. So to reduce the speed, it is trying to bend towards the normal. It is moving like this. So that means towards to the normal. Okay. Towards to the normal. So here how we can understand this one? Just by drawing the diagram, we can get understand away from the normal or towards to the normal. So the small trick to remember is nothing but by drawing the diagram we are getting this now. So by drawing the diagram we are getting this one. So in the drawing, so draw is the key point here. So draw, how the draw is the key point here? D means denser. Denser to rarer. R means denser to rarer. Then remaining two letters AW. AW means make it as away. AW. After that just add AY. Just add AY. So that is away. Away from the normal. Away from normal. All of you clear? A small trick. Denser to rarer. AW means away. Away from the normal. Okay, if you remember this one, then other one is no, not required. Rarer to denser. That is towards to the normal. RDT. Okay. Road and transport. So no need to remember. So if you remember this one, other one is rarer to denser towards to the normal. Okay. Rarer to denser towards to normal. All of you clear? So this is a very simple concept, guys. If mediums are same, just light is traveling only in the air, only in the water, only in the glass, there is no bending, there is no change its direction. Okay, that means if you are also, if you are moving in the vehicle, that is in the bike, in a straight line, only straight line. Okay, you are slowly, you are moving in a straight line means no need of your change of direction. Correct? No need of change your speed also. Whenever there is no any other vehicle is coming opposite you and other cases. Okay, except other cases. Correct or not? So here also, whenever the light travels from one medium to another medium, it changes its direction. If it changes its direction, that concept is nothing but you can say refraction. Here we have the two important points in the refraction. Those are nothing but whenever light travels from denser to rarer, draw, that is away from the normal, rarer to denser, towards to the normal. Okay. So these 2 points are very important. Here what is happening due to the refraction? Due to the refraction, there is a change in the shape. So we can observe the object size may be changes, object distances may be changes. Correct? For example, if you are using the spectacles, due to that, for example, if you don't have the specs, okay, then if you have the vision problem, then what is the use of spectacles? So by using the spectacles, we can be able to clearly see that object, correct? That means maybe the size of the object may be little bit increases, correct? Then only you can able to see. So that means due to the refraction concept, you can able to increase the sizes or you can able to decrease the sizes. Okay, in actual case, those are not at all increases and decreases, correct? Okay, but it is appears like that. For example, if you place one lemon in the glass of water, then it looks appears bigger, correct or not? Why? Because you are watching from your eye. So in the medium is air. After that, what is the medium? Glass of water. So glass. After that, from the glass you are watching through the water, correct? So that means here your mediums are changes. Whenever your mediums are changes, the sizes will be different. Okay. So in actual case, lemon size may not be bigger, correct? If it is bigger, we can place small amount of gold in the glass of water and we can get a very bigger size of the gold. That is not at all possible. Actual size is same, but if you look into from your eyes through the medium of air and then through medium of glass and then through medium of water, its size is different. So whenever the size, whenever your eye is showing wrong size, wrong shape, then the reason is refraction. Reason is refraction. Why I am giving this much of depth? Because the examples are very important. The examples are very important. Let us take some examples of refraction concept. In most of the exam, they will give these examples as a question. Some examples of refraction. Sir, this slide topic is very lengthy, sir. Yes, lengthy and most important also. Okay, I can't help. Okay, you have to listen. Once you listen, once you understand, the topic is very simple. Okay. So, what is the main examples you can say? Uh, Whenever your eye is showing wrong shape, wrong size. Okay. So, wrong shape or size, that is due to refraction. This is the key point. Okay. So, bending of linear objects. Bending of linear objects when those are partially dipped in water. Partially dipped in water. Okay, for example, let us take if we place spoon in glass of water, it appears like bend, correct or not? So in actual case, the spoon is not going to be bent if you put just into the glass of water, but it appears like that. That means your eye is showing wrong shape. Okay, that is because of refraction. Okay, because of refraction. That is lemon in glass of water showing bigger in size, correct? That is due to refraction. Okay, fish in the pond. A fish in pond where viewed from air appears to be small depth, but actual case it is a more depth, small depth than actual depth. Okay, And sun, if you can consider sun in the morning and evening, it is like somewhat of oval shape. But in real case, sun may not changes its shape, correct? So oval shape of sun, oval shape of sun in morning and evening, in morning and evening. And twinkling of stars. In actual case, stars may not twinkle, but we are seeing from longer distances now. In the atmosphere, there is a lot of moisture is there. Due to that, it is appears like a twinkling of stars. So all these are examples of this refraction concept. Okay, and letters appears to be the letters appear raised when viewed from or viewed through glass, glass, glass. Okay, so all these are examples of refraction. I think you got the refraction concept. If our eye shows wrong shape or wrong size, then the concept is refraction. Okay, so what is the main causes of refraction? That is different mediums, different refractive index. Causes of refraction, because speed of light is different in different mediums, different mediums. Okay, less in denser medium, more in rarer medium, rarer medium. Okay, and also some important points belongs to refraction, that is laws of refraction. We have two laws of refraction. Laws of refraction. The first law is same like law of reflection. The incident ray, you know very well about the incident ray. The incident ray, comma, the refracted ray, and normal, all are at the same point. The normal at the point of incident, all are at the same plane. The point of incident, all there are lie in same plane. Okay, so we can consider this is the normal, this is the incident. Okay, it is the actual. If it is moving like this is the refracted ray. So at this point, all are at this point only, na? So all the rays are meet at this point. So that is the first point. And the second law is Snell's law. Snell's law. Okay, the Snell's law is nothing but the ratio of incident ray by, this is the incident ray. Okay, this is the refracted ray. Okay, so sin I by sin R is equal to constant. Is equal to constant. That constant is nothing but refractive index. 2 with respect to 1. Okay, refractive index. Sin I by sin R is equal to constant. So you can note down the point. The ratio of sine angle of incidence to the sine angle of refraction Sine angle of refraction is constant. That is nothing but you can say Snell's law. You can say Snell's law. Okay. So after this, we will discuss total internal reflection principle, critical angle, okay, application of total internal reflection, and then atmospheric refraction. Okay, so we'll discuss all those in the next session. Okay, there is a very big topic, this light. After that, we have to discuss the lenses. Okay, concave lens, convex lens, and the image formation through the lenses. Okay, I think till we have two more sessions on this light. Correct. Okay, and also we have two more topics, interference of the light, diffraction of the light, dispersion of the light. Okay, there are a lot of topics are there. Okay, so don't worry, I will try to complete the light topic. Okay, okay students, if you like my session and if you like my efforts, try to click on a like option and also share your feedback in the comment section and also try to share it to your friends. Okay, and if you want to download the pdf you can download from sunilengineeringacademy.com. Okay, thank you so much guys.